Hi, in this lecture you will learn about the reference cursors known as ref cursors in detail. Let's first start with why we need the reference cursors. Most of the times we get some data from database, but it depends. What I mean is the select query that we need changes for some reasons. We generally create a subprogram that results us similar data, but with operating completely different data. For example, we get the salaries, but sometimes from the employees table or sometimes from the retired employees table or from a completely different query. We must have a structure that we can use a generic query. Or we want to send the cursor to some other programs like a function or even into a different platform like a Java code. With a simple cursor variable, we cannot do that. But we can do that with the ref cursors. So let's start with the reference cursors then. If you know the C or Pascal programming language, you should know about the pointers. Actually, reference cursors are just like the pointers in these languages. For ones who doesn't know, the pointers are the variables that hold the memory addresses of the actual variables. I mean, if we have a number variable or varchar, not important, it is stored in the memory and it has an address in the memory. The pointer stores the address of it. So we can easily reach to that variable in the memory with using the address that the pointer stores. The reference cursors are the pointers to the actual cursors. Actually, with this way, you can send the cursor to another platform. Since it stores the memory location of the cursors, when you send that info to another program like Java or Oracle Forms, etc., you can easily continue operating with that reference cursor in that program. So you can pass this info between different platforms. The difference of the reference cursors from the others is it is not tied to any specific cursor or select query. Since it's a pointer to the memory address of a cursor, you can easily open that cursor with another query and continue working. So it will increase the flexibility of the cursors. Actually, the main point in here is the result set is not owned by any block or client or etc. There is a result set in the memory, or we can call it as PGA, and so we can reach to that result set from any client or any block. But be aware that we cannot share a ref cursor, or we call it as cursor variable, through another server or remote subprogram. So what else we cannot do with the cursors? We cannot assign null values to our cursor variables. We cannot use ref cursors in our create table or create view statements. We cannot store ref cursors in a collection, and we cannot compare the cursor variables. Alright, so how do we use reference cursors? We use cursor variables with the ref keyword. It's the abbreviation of reference. First we declare a type of the ref cursor, then we declare our cursor variable. The things that we send between different programs or blocks are the cursor variables. We declare our cursor types in a very similar way with the other types, but with some differences. Actually, there are two types of reference cursors: strong cursors and weak cursors. Or they can be called as restrictive and non-restrictive cursors. The difference between strong and weak cursors is the return type restriction. If we specify a return type for our ref cursor, this becomes a strong ref cursor. This type of ref cursor is less error prone because the compiler will show you most of the errors before you run your code, because it knows which type of data will be queried or fetched. But on the other hand, if we don't specify return type for the ref cursor, it becomes a weak ref cursor. Weak ref cursors are more flexible because any valid SQL query will be accepted in it. But it is more error prone because the compiler cannot guess which type of data you will work on. So you may have some runtime exceptions. So we simply write type keyword, then our reference cursor type name, then is ref cursor keywords, and then the return type if you want a strong or restrictive cursor. Then you declare the cursor variable. Actually, the return type has some different options, but it will be better to see them on the examples. Then we open our cursor for some query and fetch them just like the way we know from the previous cursor fetches. we open our ref cursor with the open for keywords. By the way, ref cursors are generally used within the functions, procedures, etc., but we haven't seen them yet. So we will show them on the anonymous blocks. But don't worry, we will make examples about using them in subprograms in our further lessons, so that you will be able to see how we send the ref cursors between different subprograms. Great, so let's start our examples with the simplest usage of ref cursors and then continue with increasing the complexity. Declare. The first thing that we need to do is creating a reference cursor type. We will start with the strong cursors. Type t_amps is ref cursor, and our return type return employees %row type. Now we need to create a cursor variable with that cursor type. rc_amps is t_amps type. Now we will create a record with the same type of the return type of our reference cursor so that we can fetch into it. r_amps is employees %row type, and our begin keyword. Now we will open our cursor with some query, but we need to be sure that our query must match with the type of our ref cursor's return type. Otherwise, you will face with an error. Open rc_amps for select all the columns from employees. As we see, we simply write open keyword, then our ref cursor variable name, then for keyword, and then our select query. As you can see at this line, we can open our cursor with any different queries. We will see that. Now, let's loop and see the outputs. But before looping, I want to inform you about something. Up to now, I said that my favorite loop structure is the for in loop. But this time we cannot loop like that, because as we know, for in loop automatically opens the cursor. But in here, we already opened it. So it will try to open an open cursor, and it will return an error. So we will use the basic loop structure in our reference cursor examples. The reason that we created a record type with the same type of our cursor return type is that we will fetch into it. Now let's continue. Loop and fetch rc_amps into r_amps record, and our exit when person not found, and our dbms output. Put line r_amps dot first name. Let me copy that and concatenate with a space last name. Perfect, and our end loop. Let me close the cursor and end our block. Now let's run and see if we did correct. As you can see, we could easily get our result. Now let's change our employees table with the retired employees table and see what happens. Retired employees. Let me clear up and run again. As we can see, no problem, because retired employees table has the same structure with the employees table. So we can fetch into the record with the type of employees. But if we write departments or something, we will face with the expression is of wrong type error. Great. Now we said that we can open the reference cursor with different queries. Now let's copy some code and paste for another query. And let me write another dbms output in here to separate the outputs. And now I will change the select query. The employees, and where job ID is equal to, let's say, IT Prague. Now let's run it. As we can see, it worked for two different queries. We simply closed the first one, then opened with some other query and used it. No need to create different cursor variables. Now, since our cursor is a strong graph cursor, we can create a record of that type. Let me show you. rc underscore amps percent row type. Let's run it. As we can see, it works. But be sure that it is a strong cursor type. Otherwise, it won't work. For more, we can create a ref cursor type based on another ref cursor. How? Let me show you. Let me copy the type and paste in here and write, let's say, tamps2 and rcamps percent row type. No need to run that. We can create another cursor variable of the type of our cursor variable like the rcamps above, and then we can use it. So what if we have already declared a record type? Let me type first and talk on that later. Let me take that first and paste in here and write employees percent row type, and in here I write ramps percent type. And let me comment this line. Now, as we can see, we declared a record first. Then we use that record in our return type of the cursor with using the percent type attribute. That means if we are using a table in here, we use percent row type. But if we have a record variable already, we use percent type. So what if we need a record that has different type than a table? What if we need to create a record manually? Can we use that with cursors? Of course we can do that, but this time with a little difference. Let me show you. Now let's first declare a simple record type. Type ty underscore amps is record, and eid, it's a number, and let's say first name employees dot first name percent type, and let me copy that. Last name percent type, and department name, let me copy that again. Department stat, department name, percent type. Now let's change our record variable type. I simply clear here and write ty underscore amps. Now in here, as different from the previous ones, I will write only the record type name. So return ty underscore amps. As we understand for now, if we are using a table type as a return type of our cursor, we use percent row type. If we are returning a record type that has a tables type, we use percent type. If we are using a manually created record type, we simply write only the name of the record type, not percent type or percent row type attributes. This is what we should know about that subject. Now, we need to change our select clause to fit into our record type. Select employee ID. Let's say first name, last name, and department name. From the employees table, join with departments table using department ID column. No need to write where clause for now. Now let's change the DBMS output to see the department name too. First name, last name, and concatenate with another text is at the department of, let's say, a column sign in here, and r underscore amps dot department name. Great, let's run it. We have a problem in line 11. Let me toggle the line numbers. As we can see, we have an expression is of wrong type. So let me clear up this block and run our code again. As we can see, it works perfectly fine. So what if we need to write a query dynamically? I mean, sometimes we may want to get the query from a parameter, or we may want to create a different queries based on some different situations. Can we do that? Let me show you. Let's declare another variable. Q is varchar2 type. Let's say the length is 200. And let me cut here and write Q, and Q is equal to, let's say, our select query. Now let's run it. As we can see, we have a problem here. It says cursor RC amps cannot be used in dynamic SQL open statement. That means we cannot create a dynamic SQL for that. So why? We know that we have two different reference cursor types, strong and weak cursors. Since we are using a strong or restrictive cursor type, we cannot create a dynamic SQL because the return type is certain and the query must match with that type. Actually, the compiler needs to know the type of your query because the benefit of strong cursor type is being less error prone. But on the other hand, most of the times we need to create the queries dynamically. To do that, we use weak cursors. Weak cursors are the second type of the reference cursors that has no return type. It can be any valid select query, but because of that, it is more error prone. I mean, let's say the client may send a ref cursor to your program, including a query selecting from the departments while you are waiting for the employees data. If you do that with a strong cursor, the client will not be able to call your method. The compiler will prevent it. It will return an error before running the code. But if you do that with a weak cursor, your program will crash while running. So runtime errors are the worst. We don't want that ever. Alright, eventually, even if weak cursors have the risk to have a runtime error, we use weak cursors most of the times. Because it is easier and we need to create our queries dynamically in most cases. So how we use the weak ref cursors? It is very similar to the strong cursors but with some differences and restrictions. We simply delete the return type of our cursor. And run it. See that? Pretty simple and useful. With this way, we can get our query from another user, program, or platform and run that in our block, then return the result set or a result of some calculations, etc. to the client. So it's pretty flexible. But we have some restrictions. For example, we cannot create a record with the type of our weak cursor. As you remember, we did that for the strong cursors. Let me show you. R T underscore amps percent row type. Let me run that. As we can see, we had an error because we don't know what type of data our cursor will return. Now, let's comment that out and run the same cursor for completely different queries. First, let's declare a department record because we will query from the department table for the second time. R underscore depths is department's person row type. Let me copy our code and paste. Then change our select statement with the departments table. Select all the columns from departments. As you can see, in the first open, we did that with the variable, but this time we did that with a select query directly. Both are valid in weak cursors. Now we need to change the record because our fetch into must match. R underscore depths. Now let's change our DBMS output. rdepth.department ID and rdepth.department name. Let's clear up the rest. Now let's run it. Let's check the output values. Great. As we can see, we could use the same cursor for completely different queries and results. This is very useful when you get a cursor as a parameter. Especially when you use cursors with packages, procedures, etc., you sometimes will need to send some reference cursors as a parameter. Or if you are using Java or Oracle Forms, etc. in your work, sometimes you will need to get or send reference cursors as parameters. By the way, especially isOpen function is really useful with the reference cursors, because your program will get the cursor as a parameter from another subprogram, etc. You will need to know that the cursor is still alive or not. Otherwise, you will face with the runtime errors. Perfect. Let me show you one more thing for the weak ref cursors. Weak cursors can have bind variables. Let me show you first. Let's scroll up and write our where clause where department ID is equal to column and a random name, let's say B. And in here I write Q using and our variable, let's say 50 in here. As you can see, we use the bind variable with column B, then assign the value to that variable with the using clause. We simply write using and then the variable or value. With that way, you don't need to create extra variables, etc. to prepare your query, because most of the times you will get some values as parameters and use them in your query. To do that, you can use some different options, but this is a fast way to do that. We can have many bind variables. We write them separating with comma sign. Let's run this code and see the output. As we can see, it works perfectly. One last thing about the reference cursors. As we can see from our examples, we need to create a type for the reference cursors, even it is a weak cursor type. So if you declare that type in your block, you cannot send that as a parameter to a subprogram, etc. You need to create that cursor type in the schema level. Or you can use Oracle's predefined weak cursor type sysref cursors. Sysref cursor is a built-in weak reference cursor type that we can use in any result set between other blocks or subprograms, or even with another platforms like Java, etc. So how do we use it? We simply comment our cursor type declaration first, then write sysref cursor for the cursor type in our cursor variable. Sysref cursor. Pretty simple. Now let's run it. As we can see, it works perfectly. So if you need to use a weak cursor, you can use sysref cursor type easily. Actually, instead of declaring a type for a weak cursor, you should easily use the sysref cursor. It's a faster way, and you can send that cursor variable to anywhere, because sysref cursor is known by all the clients since it is on the database. Alright, I think we know all the details about the cursors now. So this is the end of this lecture. See you in the next one.